Today, I'll show how to train and deploy an XGBoost model on the Watson Data Platform. We'll do this from a notebook. So the first thing we'll do from a DSX project is go into a new notebook. It's easy. You just click New Notebook and give it a name. We'll be using a Python 3.5 runtime, and you can use either Spark version, Spark 2.1 or 2.0, and just click Create Notebook when you're ready, and you'll be brought into that environment. I've already made a notebook that we'll go through. So here we are under our notebook's assets. We'll click XGB breast cancer. And in this notebook, we will load some data from the scikit-learn preloaded datasets, breast cancer data, and we'll also train an XGBoost model. In this classification task, we've got features which are computed from digitized images of breast masses and a label, a classification, which tells us whether or not the mass is malignant or benign. The algorithm that we'll use to help us tackle this problem is XGBoost, Extreme Gradient Boosted Trees. The authors of XGBoost describe it as a tree-based algorithm that performs very well on tabular data. That's the kind of data we've got here in our feature set. And the model is an ensemble of weak learners, an ensemble of trees, and we're performing gradient boosting with regularization, which helps to differentiate XGBoost from some other tree-based ensemble models. So let's get started. Step one is to load the data. Fortunately, we've already got sklearn pre-installed on all the notebooks here in DSX, and we'll also import some other libraries and modules like matplotlib for plotting, and pandas. It gives us this nice data frame representation for our data, which is useful for exploration and some other functionality that we'll take advantage of in this notebook. So first, you see here, we've got sklearn datasets, load breast cancer. We load that into a Python dictionary. Inspecting the keys will let you know what we have, and you can see we've got data, the feature names, target labels, all that kind of stuff. Here we print the description of the data, just the first 115 characters, which gives us some notes and other information. What we'll do is we'll take the data from that data dictionary and assign the feature values to a Python variable feats, the labels to labels, and then we'll build a data frame quite easily with pandas to get this nice tabular representation of the data. You can see here all of the columns, those fields represent the features, and panning over we can see the label at the end. Pandas data frames have some nice and intuitive methods such as describe. You just call describe on the data frame. You can get things like the count, other univariate statistics that you might be interested in, and it will construct these for all of the fields in your data set. And see there on the label column, we've got the mean as 0.62. That means that about 62% of the records in our data set are malignant masses. You can use info to get information about the field, such as the data type or the number of entries that are not null. We've inspected and brought in our data. We're ready to begin modeling. Since we're building an XGBoost model in this demo, we will import XGBoost and some helper libraries as well. NumPy, we import it as NP in order to help us deal with matrices and vectors, that sort of thing. And scikit-learn has some other helper functions such as train test split for creating testing and training and validation sets with your data, other metrics such as the accuracy score, and we'll consider the confusion matrix after we build the model in order to help us evaluate and understand how the model performs on unseen test data. After dividing the data into test and training sets, we're ready to begin modeling. The first step is to instantiate the model. So XGB's got the XGB classifier, and we assign that to XGB model. After that, we just pass the training data into fit, and that will return a trained model object, the XGB classifier. You can see some information down below about the model after it's been fit. If we fit the model, we can use the trained model object to generate predictions for some data. You can see there we've got XTest, that's the feature set that we held out for testing, and we assign the model predictions to YPred. Then we can build a confusion matrix by comparing those values to the actual values, and we also can evaluate the accuracy. You can see here we've got 98% accuracy on the test set. XGB models have some other methods like plot importance. You can use that to plot the feature importances as we see there. We use the Watson machine learning client for Python taking a look at the docs, you can see some descriptions about how to interact with the WML API. We've got functions for publishing models, pulling your models from the repo, deployments, and so on. You can see there you'll need your credentials, which we've copied and pasted from IBM Cloud here. And then we just pass those credentials into a function to authenticate to our WML repo. Once we're ready, we just pass the model and the name of our model to client repository publish, and we'll save the model to our repo. After that, we'll be able to view and interact with the model graphically and programmatically. Now that we've saved the model, we can go back to our model assets in the project, and we expect our model to appear here. It does. XGB Cancer, created on November 8th. That's today. If you give it a click, you'll be brought to this models page in the Watson Data Platform. You can see the overview, the evaluation, and your deployments. We haven't got any deployments yet, so let's make one. Click Add Deployment online. We'll make an API endpoint. We'll give it a name like XGB Deployed B Cancer. That sounds good. Deploy. And that's it. After clicking deploy, we'll create an API endpoint for you that you'll have to authenticate to make predictions. Check it out by giving that a click. And here we are. So this is the page for the deployed model. You can see the scoring endpoint. It's online. And we've got information, the API specification about how you might interact with this model. We can take a look here. Even though we're doing this graphically now, you can also interact with your deployed models programmatically like we did before from the notebook. So in the past, we used the notebook just to save and publish our model, and we deployed graphically, but you can use the Python client for the full lifecycle of your model. API specification contains information about how to do various things on the platform, so you can list all of your deployed models, your saved models, or make online predictions, and you can get information on how to do that from the API specification after you've deployed your model. It was pretty cool that after we published the model in the notebook, it appeared here in our project assets, and that's because we've associated the Watson machine learning instance that we used with this project. You can see it here under the project settings. But suppose that we remove this from the project. If we go back over to the assets, our models are gone. So what you've got to do in order for this to work properly and intuitively is associate your Watson machine learning service, that IBM Cloud service, with your project. So here we go to machine learning, click existing, and we can choose ours. You can also create new ones here, but like I said, we've got one. We hit select. Now that we're associating this WML instance with our project, you see it's back here under associated services, we expect to find all of our models once again in our project. Let's go back to assets, click models, and there we are. If we click the model again, we'll be able to find the published model, the same information as before. We've already created a deployment. Give it a click, and there we are.